Euro-Q-Exa is the next step towards quantum advantage. It's our new system, the fourth in a row, where we are exceeding our quantum computing capabilities here at the Leibniz Supercomputing Centre.
Well, Euro-Q-Exa is a superconducting system, and this means that the electronics inside it need to work at a very low temperature. So the chip sits inside a cryostat, which is cooled down to only thousandths of a degree above absolute zero. This is in contrast to some other quantum computers which run at room temperature. So Euro-Q-Exa has 54 qubits. This is in comparison to some earlier computers which we've had, which have been 5 qubits and 20 qubits, so we're working our way up. And the system 2, which will be installed also as part of Euro-Q-Exa, will have 150 qubits.
At LRZ, we hope that quantum gives us potential for more computational power, which is needed for various fields of science and research. And with the quantum as an accelerator for the supercomputers, we believe we can make a step forwards towards more and better scientific results.
Okay, so a quantum computer is a bit like an accelerator for your computer, where you might have put a GPU or something in a computer to make it faster at particular operations. The quantum computer is also faster at particular operations. But for those other operations, you really want a normal CPU. And we've got lots of those at LRZ. So the principle is we couple our supercomputers with the quantum computer and allow a user to use both resources at the same time.
The challenges for the users of a quantum computer at the moment is that they have to do with systems which are small in size, in terms of qubit count. They are noisy. The quantum error correction is a field which is still in its infancy. When quantum error correction and fault-tolerant quantum computing will be there, then it will be really interesting for use cases to understand what is possible to do with quantum computers. But the time of testing, the time of doing research is now, because the hardware can improve only if the software and the applications grow at the same time.
The Munich ecosystem for quantum computing, the Munich Quantum Valley, is really the perfect place for us to be. It has all the different aspects of quantum computing. It has the expert, it has the laboratories, and it has all the partners we need for putting systems like Euro-Q-Exa up in our data center.